Okay, so we have this problem. So we're asked for the polar curve defined by r is equal to 2 plus cosine theta. Find the equation of the tangent line to the curve when theta is equal to pi over 6. So in order to approach this problem, we know that the equation for a tangent line of any point is equal to y minus y1 equal to the slope of the function, the derivative of the function at that point we're evaluating, which is pi over 6 for this example, times x over x minus x1. Okay, and we could interpretate this m for dy dx. Okay, so knowing this, all we have to do is find the values of y and x at pi over 6 for this function and this function for this function. So in order to find the x and y values for this polar function, first we know that if we have this right triangle and this is the value of theta, and basically this function works by you're given a value of theta and that corresponds with the corresponding value of r, which is the radius. And we know that for this right triangle, the x is the same as r cosine theta and the y is the same as r sine theta. So if you want to find the value of y, we could multiply both sides by sine theta. So we get r sine theta, which equals y, which equals to 2 plus cosine theta times sine theta, and this whole thing times sine theta. Okay, and we know the value of x would be, on the same token, you just multiply both sides by cosine theta, and then you'll get r cosine theta, which equals to 2 plus cosine theta, which is the function 2 plus cosine theta times cosine theta. Right? So basically we plug in the pi over 6 for y and x, and you'll get like y would equal to 1 plus, you'll get y would equal to 1 plus square root of 3, and x would equal to square root of 3 plus 3/4. Square root of 3 plus 3/4. You just plug in pi over 6 for this function, 2 plus cosine theta sine theta, which represents y, and 2 plus cosine theta times cosine theta, which represents x. Okay, that's pretty simple. Okay, now we get into the hard part. We have to find out what the value of dy dx would be for this function. And in order to find dy dx for this function, we would have to, we know that dy dx, you could try and convert this formula into a Cartesian formula by manipulating y and x, right? But that would really be, that would be like really useless, and like there's no point of doing that. Like to convert this whole equation into a Cartesian formula, that would not be the right track. The right track would be knowing that dy dx would be the same as dy d theta over dx d theta right? And we already know what the values of x and y are, right? And because we know y is equal to 2 plus cosine theta times sine theta, we know x is equal to 2 plus cosine theta times cosine theta. So all we have to do is find the derivatives of y and x and just plug it into this formula right here and find out what the value of dy dx would be, and then and then we're all set afterwards. That's pretty simple. You could, but just for the sake, I'll show you how to find what dy dx and dx d theta. I would show you how to find dy d theta and dx d theta. And so we know the values of dy d theta. You just use the product rule, and you know dy d theta. If you find the derivative of this, you know, of this dy d theta would equal to negative sine theta times sine theta plus 2 plus cosine theta times cosine theta. That's just product rules, and there's nothing special. And dx d theta would equal negative sine theta times cosine theta minus 2 plus cosine theta times sine theta. You know, you derive this equation right here. It's nothing special. So you find the values of dy d theta when theta is equal to pi over 6. You plug it in and find the value of dy d theta, and plug in the value of pi over 6 to dx d theta, and then use this equation right here to find dy dx. And then once you find the value of dy dx, you plug it into this formula for dy dx, and you already know the values of x and y for pi over 6 when theta is equal to pi over 6 by just using these two formulas right here. And basically you're set for this problem. You basically know how to do it now. So, but I hope you try to solve this problem before you watch the video. You should always try and do that. Okay, thank you. This is the Fall Academy signing up. Next video I will show you a harder or a calculator problem or something.